Hello, in this lesson, I'm going to review about the factoring techniques that's related to factoring this trinomial, which is also a quadratic function, right? If you recall that we have studied this function quite a bit, we studied this function, we studied the statement, the definition of this function, and we studied the various form of this function, and such as completing a square and so on and so forth, right? So this is a quadratic function. Its factoring actually was covered in most of the elementary algebra textbook. So here I'm going to take this opportunity to review those factoring techniques, and I added some more factoring techniques. As I mentioned earlier, this quadratic function can always be factored, okay? There's no such a thing that quadratic cannot be factored. It can always be factored because this is guaranteed by the fundamental theorem of algebra. Okay, fundamental theorem of algebra says that any polynomial with, coefficients, real number coefficients or complex number coefficients, they can all be factored into, if the degree is n, it's going to be factored into n factors. So for that reason, we can factor this quadratic form into, factors. Now the question is how, right? Because for simple examples such as, right, let me give you some examples, right? You might have seen this. Example number 1, say we have x squared minus 5x plus 6, right, to factor this function, all right? And you guys all have some technique to factor this, right? I have talked about a certain technique I use, but they pretty much the same. They're all similar because eventually you get the same factors. Of course, you will get the same factors. And the techniques showed up in different forms. Okay, so the form I'm going to teach is, first I review what I have taught, how to factoring this, right? So basically, I'm going to use a little table to illustrate this, okay? So I'm going to use this table and maybe with more, yeah, I think this is fine, right? So we take this form, right? What we have is that there's a coefficient because this is ax squared plus bx plus c. In our case, a equals to 1, right? So a equals to 1. So to set up this factoring, we're gonna take the 1, right? 1 is equals to 1 times 1, right? So this 1 is equals to 1 multiplied by 1. 6 is equals to 2 times 3, okay? And then we're gonna do the cross multiplication, cross product, okay? So in this cross product, okay, I'm going to add a column, okay? In this cross product, let me see if I can set something up here to symbol that cross multiplication. And I don't think I can find those symbols. I can use other means, okay? But anyway, so we're going to use the cross multiplication, okay? So you can do this on paper very easily, okay? So what it does is that we're going to multiply these two numbers and we're going to multiply these two numbers, okay? So 1 times 2 equals to 2, okay? So I will add one more column. After we add this one more column, we do 1 times 2 equals to 2, and 1 times 3 equals to 3, and we're going to add these two numbers. When we add these two numbers, we will get, I'm going to put in the last row, okay? And the sum of two 2 plus 3 is 5. So our goal is to match 5 with the number in front of x. 5 certainly does not match -5. So if this match doesn't work, we have to redo the whole thing. Okay, we're going to redo the whole thing. Okay, redo it. So still 1 is equals to 1 times 1. 6 equals to, instead of 2 times 3, I'm going to write it -2 times -3. And now 1 times -2. Okay, 1 times -2 is -2. Okay, 1 times -3 is -3. Okay, so we still do the cross product. So we basically just use this as like a board game to play until we make that perfect match. Now you see -2 plus -3 equals to -5. -5 matches the -5 in front of x perfectly. Once we get these, we got our factors. Okay? So our factor will be made from the initial setup. Okay? So now I'm going to add another column. Oops. Right here, right? So the first row will give me a factor. And the third row will also give me a factor. Okay, so let's see how we make these factors. So one more column. There. So you can see the making of these factors are like this. Okay, so let me clean this up, right? So now we found a perfect match by factoring 1 into 1 times 1, 6 into -2 times -3. And the next thing we do is to take the first row. Okay, this first row has 1 and -2. So we're going to take the 1, okay, multiply by x and subtract 2. We'll add a -2. Okay, and the third row right here, I'm going to take the 1, multiply x, and add a -3, which is subtract 3. So by this time, the factor is made. The factors are made. The first factor, of course, is x minus 2. Right? The second factor is x minus 3. And you can always check if you got the right factors. Okay, so you can always check by foiling, right? So if you FOIL, you will get the factors. You'll get factors. So this simple way of factoring is what I teach. Okay, and I know there's many different forms of doing this. And of course, we also know that it originated from the same place. Okay, if we have time, I would talk about where it is originated, and that will bring us some more insight as how to factor quadratic form like this. Okay, so let's look at another example. Example number 2. Okay, so we're going to factor another quadratic. If you like, you may like to get your paper pencil and just try it. Okay, try this technique we have here. Okay, you see the way to set it up is pretty straightforward. Okay, so if I just use this table where you just use your paper and just line up like this. Okay, so the next thing I like to factor is x squared minus x minus 6. Okay, this should be fairly familiar too, right? So once again, I'm going to take this table. Okay, I'm going to take this table and I'm going to bring my factor, bring my original expression, quadratic expression. Now, all of these things will have to be redone, of course, right? And we're going to work with a new numbers, right? But the setup is here. And we understand what to match, right? We want to match in certain, so that after we add these two numbers, we're going to match -1 perfectly. Okay, so here I'm going to put some of these stuff, right? So it can look more prominent. It could look more prominent this way. So 1 is equals to 1 times 1, right? And -6. Now you look at -6. -6 equals to 2 times -3, or -2 times 3, -1 times 6, 1 times -6. There are all these different ways we can try. So for example, if we try 1 times 6, right? If we try 1 times 6, and we still follow the same procedure, we're going to do the cross multiplication, okay? So cross multiplying. And what do we get here? 1 times 1 is 1. 1 times 6 is 6. And 1 plus 6 is 7. 7 does not match -1. So this is not going to work. This combination is not going to work. So we have to try something else. How about 2 times 3? Well, 2 times 3 does not equals to -6, right? Because we have to match -6 by choosing the two numbers that equals to -6. So one of the number 2 and 3 has to be negative. So if I put a negative sign here, right? So -2 times 3 indeed is equal to -6. So let's give it a try. So 1 times -2, this is a -2, and 1 times 3, and that's going to be 3. -3 plus 3 equals to +1, and +1 does not match -1. So this choice also doesn't work. Okay, so we just keep trying. You factoring in these methods, or most of the methods in different formats, they're just by trial and error. Okay, so now I'm going to have, I'm going to try again. This time I'm going to use 2, -3. 2, -3. If I use 2, -3, this time 1 times 2 is a +2. 1 times -3 is a -3, and 2 plus -3 is -1. So we made the perfect match. We made the perfect match. Once we made the perfect match, we can make the factor. So take the number 1, 2 in the first row. We take 1, multiply by x, right? And plus 2. The second factor we'll get by 1 times x minus 3. So we got our two factors. We got our two factors. And so these two factors are x plus 2 times x minus 3. Okay. And as always, you can always check by FOIL the product to see if we really get the original expression that was given. So FOIL the product. Okay, so now you can see in the first two examples we have, they are, you know, they're pretty much having the case of a equals to 1, right? A equals to 1 in this case, a equals to 1 in this case. Then you say, well, does it work when a is not equals to 1? Let's look at example number 3. Okay, so we're going to factor. Okay, so here we have another example. Okay, so let me grab that example. Okay. So this time we're going to have 2x squared. 2x squared. Okay. And 2x squared plus 4x minus 6. Okay. 2x squared plus 4x minus 6. Okay, we'll see how if we can factor this one. Now, before we factor this one, I actually noticed that we can actually factor out the 2. Okay, but if we don't, then just for the sake of practicing, let's do this. Okay, let's do this as it is. Okay, we'll have other examples coming our way. So now, of course, I just copy the format, right? The factors will be different. And all of these numbers will be rewritten, right? All of these numbers will be rewritten there. And now what we do here is that we look at a 2 because the coefficient for x squared is 2. 2 is equals to 1 times 2, right? -1 times -2, right? There are all these options. So let's try 1 times 2 first. Okay, so 2 is equals to 1 times 2. -6 is equals to 2 times -3. How about we just try that, right? 2 times -3. So we still use the cross product. We're still multiplying this way, cross, right? So the rule doesn't change. So 2 times 2 is 4, right? 2 times 2 is 4. 1 times -3 is -3. Then 4 plus -3 equals to +1. Does a +1 match the 4? And no, it doesn't. Okay, so we have to try something else. Okay, so how about -2? And how about -2, 3? Right? So we're going to try that. 2 times -2, that's -4. 1 times 3, that's +3. -4 plus 3 is -1. It doesn't match either. So then you just keep trying. You can see this process is a keep trying. It's actually hard to tell, can I factor this easily? Okay, we can factor for sure, but can we factor this easily, right? So you may try -1 times -2 because -1 times -2 is +2 as well. So in this case, you have -2 times -2 is +4. -1 times 3 is -3, and it doesn't make the match either, right? So this is the trial and error that many of us will have to go through, okay? So now let's try more. Then you say, how many cases do I need to try? If you really want to have a systematic ways to see, let's see how many ways I can try this, right? You would do say, okay, 2 is equals to 1 times 2. We have tried that combination. And we have tried a -1 times -2, right? And -6, right? This -6 has all of these different ways of factoring. So you can have -2 times 3, right? And you can have 2 times -3, and you can try 1 times -6, right? Or -1 times 6. So all these different ways Okay, until you run out of them, you still haven't found them. Then you know it cannot be factored easily. But don't forget, it can be factored. It just, this way doesn't find it. Doesn't find it. Okay, so let's try one more time. So this time I'm going to try 3 times -2. And 2 times 6, I'm sorry, 2 times 3 is 6. 1 times -2 is -2. 4 plus -2 is a +4. Does that make the match? Yes, it does. Okay, so you can see we take 1 times 2 with 3 times -2, that we made the match. We made the match, yay. Now we're gonna compose our factors the same way. So take 1 and 3. So 1 times x plus 3 more, and this one is 2 times x plus -2. That's a -2. Okay, so we got our factors. We got our factors. One of them is x plus 3, and the other one is 2x minus 2. So we found the factors. And once again, you can check if you found the right factors. Okay, so you just take these and factor it out, right? Factor it out, expand it, FOIL it, get to the original. It should go back to the original expression. Okay, so this is the simple factoring method. You probably have learned the elementary algebra. And your teacher may teach you in different form, but essentially it's the same idea. Okay, I'm not pushing you to use exactly my method. But my method to me seems to be pretty straightforward. So if you're more used to other ways and you get the right factors, I have no problem with it. Okay, just make sure you got the right factors. And by the way, here we can actually factor the 2 out of the second factor. So we could get x 2 times x plus 3 times x minus 1. Okay, so that is a completely factored. Okay, so now we understood the technique. Okay, we understand the technique. Once we understand the technique, right, we will see, well, there are cases that the factoring can be very, very difficult. For example, let's do another one, just to get familiar with this technique, okay? So example number 4, sorry. Example number 4, okay? And this one is, of course, is 2x squared plus 7x plus 6. Okay, of course, we want to factor it. Okay, we're going to still use this format. And of course, all the numbers has to be adjusted, right? All the numbers will have to be adjusted. It's not going to be the same factor. So each time you're going to set up this board game. And 1 times 2, but we probably can save it, right? 2 times 6, 3 times 2, right? Maybe we can try 3 times 2, right? And all these numbers have to be, redone. And this is 3 times 2. So by this time, I hope you got familiar with this format, right? So 2 is equals 1 times 2, 3 times 2 is 6. We want to match 7. So let's put the 7 here, okay, if you like, right? So 2 times 6 is, 2 times 3 is 6. 1 times 2 is 2. 6 plus 2, no, it doesn't equals to 7. It doesn't equals to 7, so it doesn't match, right? Then what do we do? How about 2 times 3? How about 2 times 3, right? Then 2 times 2 is 4. 1 times 3 is 3. And 4 plus 3 equals 7. Yay, we found it. So let's compose the factor, right? We take the 1 and 2, and 1 times 2 I'm sorry, 1 times x plus 2, okay? 1 times the first number times x and then plus 2. The second number will be 2 times x plus 3. So we got our factors, right? And then the first factor is x plus 2. The second factor is 2x plus 3. And check, right? As always check. I FOIL that. Okay, so check. So you would FOIL these, right? FOIL the factors to see if you get the factors you want, the original expression. It has to be the original expression. So that's the method, right? However, this method, okay, no matter how you use it, if you cannot find simple factors, then you cannot find simple factors, no matter what you do, no matter which trick you do. Are there situations that the simple factors are just very difficult to find? Yes, that's absolutely true. That is absolutely true. Okay, so this is the first method. Then you say, then you may ask, you told us at the beginning that this can always be factored, then we should always have factor. But if this method doesn't take us to get those factors as we wished, is there a method that to help us to get the factors always? Do we have such a method? The answer is yes, we do. Okay. So if you look at the quadratic form, right? We always have factors, and those factors actually, if you just say, okay, I want to have a way that works for me every time without exception, okay, the method that never fails, the method to factor and never fail. And what is it? Right? You can see using these methods, sometimes you get, methods very, very difficult. For example, let me give you example number 5 to try these methods before I give you that never failing method. And this is x squared plus x plus 1. Doesn't that look simple enough? Doesn't that look simple enough? Absolutely. To me, it's rather simple. But does it factor? Let's try it. Okay. Let's try it. So, okay, I'm going to remove all of these numbers. We're going to set up new ones and make a match of another number. Okay, so 1 is equals to 1 times 1. And this one equals to 1 times 1. Okay. If we do the cross product, okay, one times 1 is 1, and 1 times 1 is 1. 1 plus 1 is 2. It doesn't match the 1. It does not match. And then you say, oh, I'm going to try negative. Do that. Try negative. Try negative. Right? So this is -1. This is -1. This is -2. It doesn't match the +1 either. How about you put a -1 here? No, it doesn't match. This is a +1. This is a +1. This is a +2. It doesn't match. So these simple tricks just don't get us the factors. So this is the time we shall introduce the method to factor, and that method never fails. Okay, this method never fails. The method to factor trinomial, okay, to factor this piece, and it never fails. I think you're ready to know it, right? Are you ready to know it? All right, I'm going to review this method to you. Okay, this method is as follows. Okay, it is equal to a times x minus x sub 1 multiply x minus x sub 2. Then the question is, what is x1, x sub 1, what is x sub 2? And here's the answer. X sub 1, okay, x sub 2 are solutions to the quadratic equation. Okay, so this is the no-fail factor finding technique. And what are the solutions to this quadratic formula? And of course, you know it, right? You know it. That is, okay, that is, in the quadratic formula, we have negative b plus minus square root of b squared minus 4ac divided by 2a. Okay, if we make x sub 1 equals to that formula, the plus minus sign, we choose the negative sign, and x sub 2 is going to be same formula, we choose the positive sign. So this is the complete information about how to get those factors you need every time and no failing, no failing. All right, are you ready to try this method? Are you ready to try this method? So let's try this method, okay? To see how it will never fail us. It will never fail us, okay? I guarantee you, okay? Starting from the first one, starting from the first example we did. Okay, so we use that method, right? We use that method. So back to example number 1. According to this format, right? It should equal to a times that, right? We just plug in numbers. So what is a? A is 1, therefore it should equal to 1 times that. And x1, x2 are solutions to the quadratic equation. So we're gonna set this guy equals to 0, right? You know that's to find the x-intercepts of a certain quadratic function. Now, the quadratic formula, how did we try to find the quadratic formula? Well, we can find the discriminant, right? We can find the discriminant, or you can just plug in, right? So a is equals to 1, b is equals to -5, c equals to +6. Okay, so all we have to do just plug in. Negative b is negative b is -5, and b is -5, and a is 1, c is 6, a is 1. So we simplify this expression. We got negative of -5 is a +5, plus minus, under the square root is 25 minus 24. 25 minus 24 is 1. Square root of 1 is 1, so divided by 2. So our x sub 1 is equals to, say, 5 minus 1, right? 5 minus 1 divided by 2, that's equals to 4 over 2, that's going to be positive 2. And x sub 2 is equals to 5 plus 1 divided by 2. And that's going to be 3. Okay, so have we found our factors? Well, we just plug in x1, x2. So this is 2 and that is 3. Have we found the same factors as we did before? Have we found the same factors as we did before? Yes, we did. Yes, we did. Right? We found the same factors. The second example, it works too, right? So let's try one more time. So the second example to factor, so instead of using that simple method, right? How about we just use this method that never fails? It's a little bit more work. Yes, it's a little more work, especially I know some of you can just factor using that method in your head, right? Now, this time we're going to apply the same method. No problem, right? So okay, it's going to be this form. A is 1 and 1 can be omitted. We just need to identify x1, x2, right? And the solution to this quadratic equation and plug in, right? Plug in. And what is A? A is equals to 1, B equals to -1, right? C equals to -6. Now we just plug in. B is -1, and B is -1. A is +1. C equals to -6. Denominator 2 times 1. 2 times 1. Okay, so I'm going to put this down. Under, put the parentheses here. Well, that's 1. -1 squared is 1. -4 times 1 times -6, that's 24. So 1 plus 24. 1 plus 24 is 25, right? So this is going to be 25. The square root of 25 is 5, right? So here you get the square root of 5. And of course, negative for -1 is a +1. So this is a +1, right? So we got x sub 1. Okay, so x sub 1, x sub 2. Right, so x sub 1 is 1 minus 5 divided by 2. X sub 2 is, so 1 minus 5 and 1 plus 5. Right, so what do we get? This one we get -2, and this guy, the other guy, we get this 3. Have we found the factors? I think we have. I think we have. All we have to do is just replace x1 by -2. Replace x2 by 3, right? Minus -2 is +2. Have we found the same factors? Absolutely, we have, right? Are these the same factors? Yes, they are the same factors. Exactly the same factors. Isn't that interesting? Yes. How about this one? Of course, this is not proof, okay? If you want proof, we can definitely prove it, okay? Example number 3. Example number 3, right? When A is not 1. Does this method work? Yes, it does. Okay, so we're going to use this method one more time. Okay, we just put it here. It works, right? So we just have to apply it. A this time equals to 2. A equals to 2. okay? X1, X2 are solutions to the solutions here. Okay? Do you guys see that? Okay, so now let's apply the formula, okay? So what is A? A is 2, right? B is 4. C is -6. So B is 4. So -4. 4 squared. -4 times 2 times C is -6. -6. You just have to be very careful here, okay? A is 2. Okay, we're going to bring down the X1, X2. Okay, let them wait for us. Okay, so next. All right. So -4 is here, just leave it there, right? 4 squared is 16. And 4 times 2, -4 times 2 times -6, this is 8. So -8 times -6 is plus 48. Okay, so it looks like that's going to make 64, right? So here is 4. So keep going. We have a square root of 64. And the square root of 64 is 8. So there we have, that's going to be 8. Okay. And next, okay, we're going to make our x sub 1, x sub 2. So x sub 1, and that's x sub 2, right? So this is going to choose to be negative, and this is going to be positive. And what do we get here? This one we got -4 minus 8. That's -12. -12 divided by 4 is -3. Okay. And this one is going to equals to 1, right? -4 plus 8 equals 4. 4 divided by 4 is 1. So have we found our factors? Have we found our factors? Let's see. 2 times x minus x1. x1 is -3. And x2 equals to 1, right? And to simplify, minus -3 is a +3. So that equals to 2 times x plus 3 and x minus 1. Do we get the same factors in example 3 earlier? Yes, we did, didn't we? Yep, that's exactly what we got. Now, finally, we come to the number. Oh yeah, we haven't done number 4, right? So let's do number 4, okay? For number 4, if you like to try it yourself, why not? Right, this is the factor we got, right? This is the factor we got. So what do we have is that we're going to apply this method. Right, we're going to apply this method. And so we put it over here. Right? And A is 2. Once again, and we need to find x1, x2. And x1, x2 are solutions to this quadratic equation, which is equal to 0, right? To find x-intercept. And then we just need to plug in. Okay? Plug in the A equals to 2, B equals to 7, C equals to 6. Okay? So now let's do it. Let's do it. We're going to have x1, x2 wait for us, right? Wait for us later. So negative b is -7 plus minus 7 squared minus 4 times a is 2, c is 6. A is 2 there, okay? And let's simplify that. We have -7 plus minus 49. 49 minus 48, right? 48. 48. That's equals to 1. So this is 4 equals to, and so we got 7 plus minus 1 over 4, right? So we have two solutions. One is this piece, and the other one is the one is chosen using negative sign minus, and the other one is a plus. Okay, I hope that's clear to you. Okay, and simplify. So that -8 -8 divided by 4 is -2. And this is going to be -7 plus 1 over 4. That's going to be -6 over 4, right? -6 over 4. And that's -3/2. -3/2. All right. Let's put, oops. Okay, so let's bring them in. Let's bring them in here, right? So we bring them in, x1 equals to -2. So I'm going to put -2 here, right? x2 is equals to -3/2. Okay, -3/2. Then you say this looks different. Is it? Is it really different? Okay, so let's work it out. So let's work it out. So we have 2 outside, x minus -2, that's x plus 2. And the other parentheses, you're gonna have x plus 3 over 2. So x plus 3 over 2. What factor did we get before? Example number 4, we got this piece, right? We got this before. Is this different from that? Recall, right? This is what we got before. Well, what can we do to see if they're the same or not? Well, this is what you can do. You can take this 2 to multiply to this parentheses, okay? So you're gonna take, whoops. Okay, you're gonna take the x plus 2 to the front. Okay, and move the 2 to multiply the second parentheses. And you're going to take this 2 to multiply every number inside the second parentheses. Okay, so what you get is that you have 2 times x, 2 is coming inside, and 2 times 3/2, and you're going to get exactly the same factors. You're going to get exactly the same factors. So this works once again. Okay. All right. So you can see this method works for all situations that we can factor using our simple method. Then how about the case that we have a very difficult time to factor, right? That number 5. And I promise you it can be factored. It's just we haven't found the factors. All right, let me show you. Okay, will this method work? The answer is yes, absolutely. Absolutely. So this same situation will also work. In this case, a equals to 1. It's just this method is not going to make it. It's not going to make it. Okay, so now let's find x1, x2. Let's find x1, x2. Okay, so we're going to have a quadratic equation, and that quadratic equation is just setting this function equals to 0. The output equals 0. Okay, we set equals to 0 as we did in the previous cases. And here, A equals to 1, B equals to 1, C equals to 1. Isn't that simple enough or what? But it's just very hard to factor. So now this method will give us the factors. Okay, so B is equals to 1. So this is minus 1, 1 squared, 4 times A is 1, C is 1, A is 1. So we substitute the numbers properly, okay? And then we are going to simplify. So 1 squared is 1, 1 minus 4 is -3. Okay, now 2 times 1 is 2. And it looks like we're entering the complex number territory. Okay, so we're gonna have root 3 times root of -1, and root of -1, that's an I, right? So that's an I, so we're gonna put the I over here. So what is our x1, x2 then? We got our x1, x2 here. Okay, so x1 will be this guy. x2, this will be the minus, and this will be the plus. We found our factors. We found our factors. Okay, so now it's time to put it back in. Now it's time to put it back in and to get our factors right here. Right here. And x sub 1 is this piece, and x sub 2 is that piece. Then you may say, wait a minute, is it going to work? Of course it's going to work. Well, in the previous 4 examples, we did 2 different ways to factor them. We always checked our answer, right? We checked our answer before. So the second time we used the second method, the no-fail method, we didn't check. But this one, we didn't factor before, so we have to check it this time, right? So let's check it. Let's check it. Let's check to see if we actually get to the original. So we're going to FOIL this piece. Okay, we're going to FOIL this piece. Okay, so let's focus on the foiling. I want you guys to pay attention to every single details that I did here. Okay, now I'm not in a hurry to multiply yet. I'm not in a hurry to multiply. So what I like to do is I'm going to separate the real number part with the complex number part. For that reason, I'm going to use some bracket. I'm going to use a bracket. Okay, because inside here, I'm going to put them in parentheses. Okay, I'm going to separate the real part with the imaginary part. So separating the real part, I will get this piece. Okay, subtracting the root 3 divided by 2. So basically this piece, I separate it into -1 minus I times root 3. So I'm going to put the I here. Okay. On this piece, I will do the same thing. I'll be doing the same thing. Okay. Except that this piece is adding. Okay, so I'm going to put the I over here. Okay, so -½ you can see -½ right? I can even put the negative sign in front of it. Makes no difference, they're the same number. All right, if you have to pause and watch this piece over, do that. Okay, you need to get to these details. Okay, so I put this piece into the real part and the complex part. Okay, so -1/2 plus I times root 3 over 2. Okay, so this is minus, 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 plus. And next, I'm going to open up the parentheses inside the bracket. Okay, so this negative sign would apply to each term. Okay, so I'm going to remove this. So here, this is going to be plus, and this is going to be plus. Okay, basically this negative sign distributed to this piece and to that piece. So that's how we get this piece. Okay, on the second part, we're also going to distribute the negative sign to this piece and to the next piece. So here is going to turn into positive, and over here is going to be negative. And every one of us need to be able to handling this level of algebra very well. Okay, now regrouping. Okay, I'm going to put these two together and put these two together. They're the same. Okay, they are the same. So now if you look at these two brackets, if I see this piece as a capital A, right? So let me put this here. If I look at the first bracket, okay, I'm going to put it this way. Okay, I'm going to call this a capital A, and so this is a capital A. This piece, capital B, so that's a capital B. So we have A plus B times A minus B, isn't it? So we have a case of A plus B times A minus B. And what does that equal to? We all know that, right? That's A squared minus B squared. Okay? Okay, so that's A squared minus B squared. And what is A? Our A is this piece. A is that piece. B is this piece, right? That's the B. So B is that piece. B is that piece. So we apply this formula. All right. Of course, we're gonna have to FOIL this piece, right? But before we FOIL that piece, let's look at the second piece, right? So we're gonna FOIL that piece. We're gonna come back to FOIL that, okay? Minus the second piece. The second piece will have I squared. I squared multiply root 3 over 2 squared. Right? And then of course, now we can FOIL this part. We can FOIL this part. How do we FOIL that part? When we FOIL that part, you can use this formula, A plus B squared, which equals to A squared plus 2AB plus B squared. What does that mean? X plus 1, X plus half squared, right? So X plus half squared. So, whoops, sorry. So A is X, right? So X takes the place of A. So everywhere A becomes X. B is half, right? So everywhere B is replaced by half. Everywhere B replaced by half. Everywhere B replaced by half. All right, so when we FOIL this piece, do this on the scratch paper, okay? Do this on the scratch paper. So X plus half squared is X squared plus 2 times X times half plus 1/4. So 2 times half, that's 1. So this piece is going to be equals to that. and just simplify that. Simplify it. Okay, and that's going to be x. And that's going to be a quarter. Okay, that's going to be a quarter. And this piece in the bracket, I actually can remove the bracket, really. Okay, I can remove the bracket. And then what? Then what? Let's keep going. What is I squared? What is I squared? I is equals to square root of -1. So if I square both sides, I squared equals to -1. I squared equals to -1. So I squared is equals to -1. √3 over 2 squared, right? √3 over 2 squared. So it's like √3. If I opened up the parentheses, I square the top, right? And I square the bottom. So I will get what? I get 3 over 4. Okay, so these are the details everybody must learn to do. And so negative on -1 times 3/4, so that's just going to be plus 3/4. So in the end, what do we get? This piece equals to 1. Isn't this just where we started? Yes. Okay. So you can see it works, but what will be the preferred form of the final answer? The preferred form of final answer, you know, we have simplified all of these, right? It's actually this piece. This is the preferred form. This is the preferred form, okay? And you can remove these brackets. So that would be the preferred form if you just put them in parentheses. That's it. That's it. Okay. So you use that no failing method to factor. And in the end, you want to express it with the real part and the complex part separated. Okay, so this is a no fail method to factor. This is a no fail method to factor. Okay. And I think we shall try some other methods, right? We shall apply this method to other cases. So we have done example 1, 2, 3, 4, 5. I hope you get it. Okay, you certainly have homework to help you to practice on that. Example number 6. Okay, example number 6. Example number 6. We're going to see some more situations of a similar nature. Okay, we're going to see some more situations of a similar nature. Typically, it is a little bit difficult to factor by the simple method, or you just don't want to do the trial and error. Okay, but any way you wish for, any way you wish for, right? So, for example, I'm giving you this situation, right? Factor. We got a -2x squared plus 4x plus 3. Okay. Shall we try the simple method? Okay, why not? Let's try it, right? We have it. Let's give it a try. It may work, it may not work. We always keep in mind these methods we learn, sometimes it works, sometimes it doesn't work, right? But if it doesn't work, we have another way to deal with it, right? So let's do it. Let's do it. So now we have a -2 in the front. So -2 is 1 times -2. You can try a different combination, okay? 1 times -2. How about 3? 3 is equals to 1 times 3. 1 times 3. Okay, I wish I can interact with you, but I have to do this solo here. And then cross product, cross product. Okay, so if you found a factor, you can fast forward, okay? Because I can be slow, okay? -2 times 1, that's -2. 1 times 3, that's a 3. -2 plus 3 is 1. 1 does not match 4. Oh no, it doesn't match, okay? So let's try 3 times 1, right? So 2 times, -2 times 3 is -6. 1 times 1, and we get a -5. It does not match the 4. Oh no, doesn't match. What are we going to do? Well, we just have to keep trying, right? Because you have to factor this. And what else? Shall we switch this to be -2? To be -2, 1 here? Why not? Then we get 3, -2. Oh no, we get to 1 again. It looks a little bit helpless. It looks a little helpless. You know, at this point, guess what will give us a simple and quick method to determine whether we should just stop trying. At this point, we haven't found a factor. Can we say it cannot be factored? Absolutely not. Absolutely not. If you make that a conclusion, you're going to lose a point because it can be factored. Fundamental theorem of algebra guarantees it can be factored. It's just we haven't found a factor. A quickie way to do this would be doing the b squared minus 4ac. Okay, so b squared minus 4ac, okay, will give us a quick peek. Okay, because if b squared minus 4ac is a perfect square, we are looking hopeful. Otherwise, we better give up as soon as possible, okay? So our A is -2, B is 4, C is 3. Okay, A is -2, B is 4, C is 3. So I'm going to plug in B squared is 4 squared. Minus 4 times A is -2. C is 3. What do we get here? We get 16 plus 16 plus what? -4 times -2, that's a +8. 8 times 3 is 24. And what do we get in the end? We get a 40. 40 is not a perfect square. 40 is not a perfect square. This tells us the factors are going to be pretty difficult to find, or we cannot find the factors using this simple method. Just forget it, okay? And you'll find out soon why, okay? So at this point, I try it, it doesn't work, and I'm just going to quit, okay? I'm quit using that method. I'm not quitting factoring because I know I can find a factor using the other means. So x minus x sub 1 multiply x minus x sub 2. Okay, and we know how to find x sub 1, x sub 2, don't we? Quadratic formula, da-da, right? So 175%. I'm just making the fonts a little bit larger. I already have the discriminant. Okay, so when I plug in, my b is 4. My b is and I can just plug in the whole thing. This is a 40. right? And A is -2. A is -2. This is looking good, right? But we have we don't have a perfect square inside the square root. Okay, so here we get -4, and I have a -4 on the top, plus minus root 40, right? Root 40 is root 8 times 5, or 4 times 10, right? 4 is a perfect square. 4 is a perfect square, right? So now we get into the situation that perfect square 4 can be brought out. So there's 2 here, right? And we're getting closer to that. You can reduce here, actually. You can reduce here because we have a 2 inside here, 2 inside here, we have a 2 inside there. Okay, so we can write it as 4 is 2 times 2, 4 is 2 times 2. So from each term, we take away a 2. So we, in the end, we get the 2 is gone, this 2 is gone, and this 2 is gone. So this is simpler, isn't it? So now we got our x sub 1. X sub 1, oops, x sub 1 equals to this piece. Right? I choose the minus sign. Doesn't matter. And the other piece, I'm choosing the positive sign. Now we got our x1, x2. If you like to simplify, which I would like to, right, is that you see there's a negative sign on the top. So on the top, I have negative sign inside the parentheses, which is 2 plus square root of 10. Right, in the bottom, I have a -2, right? So these 2 negative signs can be reduced. You know what I mean? So that will make it a little simpler. Okay, so this equal sign, negative takes away the negative, so you get that. And this other one, you can do similar things if you wish. Okay, you can factor out the negative sign. Okay. And put it in parentheses. You have 2 minus root 10. And the -2 on the bottom. And this way, the negative sign reduced. So you're going to have 2 minus root 10 divided by 2. It just looks a little cleaner. It looks a little cleaner, okay? So these are the 2 roots we have. All right. We are almost there. We are almost there. So we're going to bring them in, right? You can see this situation is a little messier. It's a little messier, okay? And you may also understand why people want to use the simple method to factor if they can. But if we cannot, that's not the end of the world, right? So replace x1 by its equal, replace x2 by its equal. And we wish to separate the number part with the radical part. We do, okay? We wish to separate the number part, the whole number part with the radical part. So to do that, this is what you can do. Okay, you have -2. So I'm going to bring these, I'm going to put these in the bracket again. Just to keep things in order. Okay, better organized. Okay, so I'm taking this 2 to divide into this 2. So I'm going to put this in parentheses and put these in parentheses. So 2 into 2, so plus root 10 over 2. Okay, so 2 over 2, that's 1, right? In this parentheses, you're going to do 2 into 2 and minus, right? So you take this piece, you do the minus over 2. Okay, so this is a minus 1. This is minus 1. So you just try to make it look nicer. Okay, and then you can open up the parentheses, right? The negative sign, open up the negative parentheses. So this will be negative, and open up this parentheses, and this is going to be plus. So in the end, the factor form, you can leave it like this. You can leave it like this. Okay. If you leave it like that, you could put parentheses, even though it doesn't matter. You can keep the bracket. That's it. That's it. Did you guys notice something? Did you guys notice that the 2 roots are always a conjugate? Are they conjugate? Okay. Did you notice, or have you noticed that the 2 roots, the 2 roots of quadratic equation which is ax squared plus bx equal plus c equals 0 are always conjugate? Did you notice that? Right? Then you say, what is a conjugate? Do we remember what are conjugates? Okay, what are conjugates? What are conjugates? Okay, what are conjugates? All right, so let me tell you what are conjugates. Okay, any number, any 2 numbers in this form, in the forms of a plus b and a minus b are conjugates. All right, you saw conjugates, right? But what are conjugates, right? What are conjugates? Well, when we have a polynomial, right? And say in the trinomial case like this, the coefficients are real numbers, okay? That is, right? A, B, C are real numbers. The solution to that quadratic equation are always conjugates. Then you say, well, what are conjugates? That any 2 numbers in the form of a plus b and a minus b, and they are conjugates. the conjugates property actually is embedded in the formula, right? You can see x1, x2, you can see the first one can be written as, the first one that can be written as negative b over 2a, right? And the second part is minus b squared minus 4ac over 2a, right? And the next one is negative b over 2a plus, so you can see these two numbers are conjugate to each other. And this is a capital A, capital A, capital A, capital A, and this is a B, right? So one is A minus B, the other one is A plus B. Okay, so this conjugate relationship is embedded in the quadratic formula. Okay, and furthermore, you can see this very clearly, right? And you see in this case, this it's in the form of 1 plus root 10 over 2, right? And in this letter form, it is 1 minus root 10 over 2. So they are conjugate to each other, right? They are conjugate to each other. In the earlier form, and it's even more obvious, they are conjugate to each other, right? So one is minus, if you write them in the in the form of a real part, which is negative half, right? Minus I over root 3 over 2, right? And this is latter one, this x sub 2 is negative half plus, so they are conjugate to each other. They're conjugate to each other, right? So you can see these pairs are conjugate. These just verify, okay? They are always conjugates. And then you see, how about these two numbers? Are they conjugate to each other? Yes, they are, okay? They are basically negative, they are conjugate, but they are negative 7 over 4 minus a quarter. So you can see it that way, right? So x sub 1, okay, x sub 2, right? In terms of these two numbers, and the first one is negative 7 over 4 minus a quarter, right? And x sub 2 is negative 7 over 4 plus a quarter. So that in that way, they are conjugate to each other. So these two are conjugate to each other too. Okay, it's just not as obvious. Okay, and in these situations, they are conjugate. They are conjugates. And there's just all of these relationships are embedded. They are embedded in the relationship in the quadratic formula. Okay, they are embedded in the quadratic formula. So we see these conjugates. So what else can we learn about conjugates? Right? What else can we learn about conjugates? So this will relate to how come we have the method, why we have the method we talk about at the beginning, right? So how did we get this method? How did we get this method? Okay, so I'm going to explain that to you. Okay, so now we know that for this quadratic formula, right, the two solutions are conjugate to each other. So x sub 1 plus x sub 1 is such, x sub 2 is such. And what if, look at this, okay? If we take x sub 1 plus x sub 2, what do we get? So we take this number, adding this other number, We're adding x sub 1 with x sub 2. What will happen? When we add these two, and these two will be doubled, and these two are opposite. Okay, and what do we get? Right, so these two will make 0. So we'll have 2 times negative b over 2a. We have 2 of them. And in that case, it is equals to 2 and 2 reduced. So it equals to negative b over a. Okay, isn't that interesting? So the solution, you add them, right? You get a negative b over a. And what if we multiply these two numbers? Okay, if we multiply these two numbers, x1 times sub x sub 2. So the two roots, if we multiply them, so this number multiply the other number. They are, remember, they're conjugates, right? They're conjugates. So it's a minus b times a plus b. So that's going to equals to what? That's going to equals to a squared minus b squared. Okay, so we have a minus b. This is a minus capital B. So a minus b times a plus b. A plus b, right? A plus b. We know that equals to a squared minus b squared. Okay, so now we got our a is negative b over 2a, and that is squared, minus b squared. So this is our big B squared. And what do we get? Okay, we square this, we will get b squared, right? Negative number squared is going to be positive. So this is going to be 4a squared minus, right? This piece being squared. So we're going to get the denominator squared, that's a 4a squared. The top squared is just going to be b squared minus 4ac. So b squared minus 4ac. Ha, we got the same denominator. We got the same denominator. And we keep the same denominator. And we subtract the numerator. So b squared minus b squared minus 4ac, that becomes plus 4ac. 4a, take away a 4a underneath, so we get a c over a. Let's just look what we have found. We found that the two roots of the quadratic formula, if we add them, it equals to negative b over a. And if we multiply the two roots, it equals to c over a. Isn't that interesting? Okay, this is rarely taught in most of recent textbooks. Okay, I don't know why recent textbooks omitted these important properties. Okay, so let's verify. We just proved it. So let's verify if they apply to our situation. Okay. Go back to our first example, right? Our first example. In our first example, we have our x sub 1 equal to x sub 2 equals to 3, and it's obviously, right? Obviously that x1 plus x2, which is 2 plus 3, right? Which is 2 plus 3. That's 2 plus 3 equals what? Equals to negative b over a. What is b? B is negative 5. A is 1. Are they equal? Yes, they're equal. So that is true. And to multiply 3, equals C over A. C is 6, A is what? A is 1. So that is true again. True. Okay, it is true. So let's look at the second example. Let's look at the second example. So x1 plus x2, so negative 2 plus, so negative 2 plus 3 equals to negative b over a. B is negative 1. A is 1. So they're the same again. It's positive 1, right? So negative 2 times 3 as C over A. C is negative 6, A is 1. It's true again, right? Let's look at the third example. Does it work? Does it work? So x1 plus x2, x1 is negative 3, right? So this is negative 3, and x2 is 1, right? So the left-hand side is negative 2. B is 4. A is 2. B is 4. A is 2. Negative 2 equals negative 2, correct. Negative 3 times 1, C equals to negative 6. A equals to 2. They're the same again, okay? So now, number 4, does it work? Does it work? So if we check this relationship, x1 is negative 2, right? So this is a negative 2. X2 is negative 3/2. On the right-hand side, hold on. So this is just be minus, okay? Negative 2 minus 3 over 2, negative b, b is 7. A is 2. Is that true? Yeah, that's true, because this will be negative 4 over 2, right? Negative 4 over 2 minus 3 over 2, that's negative 7 over 2. It works. Okay, x1 is negative 2. X2 is negative 3 over 2. So when we multiply these two numbers, equals C over A. C is 6, A is 2. C is 6, A is 2. It's true again. It's true again. Last but not least, right, in this case, right, x1 plus x2, where did I have that? Right here. Okay, so I just don't want to type it over. Okay, so in this case, when we check it, x1 plus x2, this is x1. That's x2. When we add them, right? When we add them and the left-hand side, then you can see these two are reduced. So we get a negative 1. So B is 1, A is 1. So negative 1 equals negative 1. That works, right? When we multiply these two, x1 times x2, it still works, okay? Trust me. We have proved it. We have proved it works. Okay, C over A, that's 1 over 1. It works again. Okay, it's just the conjugates, right? So if you want to check it on this side, it's going to be -2 squared, right? It's going to be negative, I'm sorry, -½ squared. -½ squared. Because we multiply these two, they're conjugate. So that's minus b squared. Okay, and this is a quarter, and this is going to be minus, and I squared is -1, so that's equals to 1. So you just basically get a quarter plus 3/4. Okay, I squared is -1, and then you multiply. Oh, this is subtracting, so this is going to be 3/4. So that equals to 1. That equals to 1. Okay, so it does work. Okay, it does work. So at this point, we have studied quadratic and its applications, but I just promise you, I'm going to show you how this property is used in the factoring method from the beginning, right? Remember this simple method, right? This simple method. The simple method says, you just set it up this way, right? So x sub 1 plus x sub 2 equals to negative b over c, b over a, and x sub 1 multiply x sub 2 equals to c over a. Okay, in the case of a equals to 1, okay, I'm just make a simple case to show you. In the case of a equals to 1, right? So this property, right? So now, of course, we know the roots. You know the quadratic formula for x1, x2, right? So I don't need to repeat it. So I'm going to bring it here. Okay, the quadratic formula for that. Okay, I'm going to put it right here, the quadratic formula. Okay, solution to that piece. Just want to make it complete. Okay, so these are solutions. So we know that in the case a equals to 1, and the two roots will satisfy the following relationship, because a equals to 1, so b over a is just b. Since a equals 1, so that's just equals to c, right? So if you look at this situation, right, you think about the method we split. You think about the method we split. So how did we split, right? We split 1 equals to 1 times 1. C equals to what? C equals to what? Something times something else, right? -2 times -3 equals to C. So we're really trying to guessing what are these two, what these two numbers are. Okay, we're trying to guess these two numbers, what these two numbers are. And then we try to match the number. When we add these two, we do the cross multiplication. When we add these two numbers to match the 5, we're trying to find the pair, right? Find these pair that matches the sum equals to the number in front of x, which is b. So this simple method of factoring is really inspired by this observation. Okay, it's inspired by this observation. So this is where the method originated. It doesn't matter how you set up, okay? Eventually, you just work on the C, right? You work on the C because C equals to the product of two roots. So you just to guess which factor, which combination will make that factor, will make that C. So that has to satisfy this condition. So that's why we're making the match. That's why we're trying to make the match. But anyway, I hope this explanation is somewhat enlightening for you to see through what is what is so useful about the quadratic factoring technique, right? So we have a method which is simple, and many of you master this method, but we obviously have obstacles, right? We don't always get factors easily, and we also have this no fail method of factoring. Okay, so that no fail method of factoring, I'm going to put it here. Okay, so this quadratic form can always be factored into these two forms, which is x minus x sub 1, and the other one is x minus x sub 2. Okay, and with that relationship understood, you can try the simple method. Okay, and of course, simple method is simpler. If you have factors, easy factors, a lot of academic questions can be factored in the simple method. But there are also some academic questions, the factoring may not be as easy. Okay, and we also see the omnipresence of b squared minus 4ac and its role in the factoring schemes. Okay, so I hope this method, these lessons will help you to understand factoring quadratic function in general. So finally, okay, if we combine this method with our earlier, okay, perfect square method, making a perfect square method, right? So we have general form, perfect square form, and factored form. So we have these three forms. We have these three forms. All of these three forms, they have their certain, we don't need that. All of these three forms have their, their purpose, right? For example, in the perfect square form, you can identify index, right? I'm sorry, you can identify vertex. In this form, you can identify x-intercepts, right? So in this form, we can identify vertex, right? The vertex will be HK, right? In the latter form, you can identify x-intercepts, if you have two real numbers, If you don't have real numbers for x1, x2, then you don't have x-intercepts, okay? And so we have those discussions, and I'm going to put those discussions in here as well. So there, okay, the discriminant, right, which equals to b squared minus 4ac, right? If d is positive, there's three cases. If d is positive, then there are two x-intercepts. There are two x-intercepts. Okay, there are two x-intercepts. And the two x-intercepts are x sub 1 comma 0 and x sub 2 comma 0, right? And x sub 1, x sub 2 are basically given by quadratic formula. Okay, if the discriminant is 0, right? And there's one x-intercept. One x-intercept. Okay, and that is the in that case, you have negative b over 2a, comma 0. That's the x-intercept. Okay, that's the x-intercept, basically negative b over 2a, because this piece is 0, right? if D is zero, D is negative, right? There is no x-intercept. No x-intercept. Okay, in terms of solutions, right? In terms of solutions. Okay, so we continue. So the quadratic equation, right, has two real solutions. Has two real solutions. In this case, right? Solutions, two real number solutions, which are x1, x2, right? In the second case, if this solution, it has one real solution, singular, okay? Then in this case, in the last case, as it has two complex solutions, right? So I think this will be complete in terms of quadratic functions, okay? In terms of quadratic function. So let me put it here. Just put it here. So this will be the right context, right? So in terms of quadratic function, we have covered over here and there, multiple places in recent weeks. And this was, a review. And in terms of the solutions, intercepts, and so on and so forth, right? I think we're gonna summarize right here. Right, D is when the discriminant is larger than 0, there are two x-intercepts and they are here, and you can find the numbers over here, right? So I can just put it over here, right? And if the discriminant is 0, there's one x-intercept, and that solution would just be still the same, but because this piece is 0 and that piece is 0, so these two solutions are the same, right? That's how this number, a negative b over 2a, gets to be there. Okay, so let me make sure you see that there. Okay, so because in that case the two solutions are the same. Right, so let me repeat that part. So in this case, the two solutions are the same when discriminant is 0. So this piece will be 0, and that piece is 0. You can see they have two equal solutions, which is a negative b over 2a. So that becomes our solution. So that's how we simplify it like that. There's one real solution. When the discriminant is a negative, there are two complex solutions, and these two complex solutions are these two. Okay, they're these two. In terms of completing a square, we have covered that. We're not going to repeat it here, but if you need help, please let me know. You can watch the previous recordings. If you still need help, please don't hesitate to reach out to me. And today we study the factoring techniques to factor a quadratic form. We talk about there's a one factor form, simple factoring methods, which have been taught in various algebra courses. And here we introduce a no-fail technique for factoring it, which is also making use of the quadratic formula. And this method works all the time, every single time. And we also give you some insight about why this simple method is developed, right? It's developed based on this observation, okay, based on this observation. But anyway, without further ado, and I think I hope this lesson is thorough enough, and let me know if you have anything else for me to cover. And until then, thank you for watching.